right? So that is there. Now, a couple of things, right, should have actually mentioned in the start when discussing cosine and sine, etc. only. But yeah, just a small note, and pretty sure you would know this already, right? Like for example, for ABC, this is ABC, cos A is B square plus C square minus A square upon 2BC. For obtuse angle triangle, if the angle A is obtuse, then cos would be negative. So basically, cos, like for an obtuse angle triangle, obtuse at A, this entire thing would be negative. So to say that basically A square would be more than B square plus C square. Again, these are direct outcomes of this formula itself, so not no need to basically put in extra notes for this. But yeah, essentially this is the test for whether a triangle is obtuse or not. So basically you take the largest, and again in a triangle the largest angle will be opposite to the largest side, which is intuitive, right? Because the longer I keep, let's say, this base expanding, the bigger this angle will get. If I extend this to here, then it will get even bigger. So the longest in any triangle in general, the longest side will be opposite to the highest angle, or vice versa. So if you know the longest side, you can find out whether a triangle is obtuse or not by working the cosine law on this angle. If this is the longest, if for example, if let's say this was the longest, if let's say this was the longest given, then you would have to apply the cosine law on this. If basically the cosine law on this gives you a negative number, then the triangle would be obtuse, right? Because to say that, okay, if the largest angle, or if it is giving you a positive number, then the triangle would be acute. Because if the largest angle itself is giving you a positive, then the other angles are still smaller. So if the largest angle itself is sort of acute, then the other angles will automatically be acute. So you need to only test for the longest side. And this again comes on use when you have questions like, okay, two sides of a triangle are given. What can be the range of the third side for it to be an obtuse angle triangle? Right. For example, let me just take a question, right? For example, two sides of a triangle are given as uh, anything 10, 12, and you need to find the range of the third side such that the triangle is obtuse. Right now, as we saw that for obtuse, you need to work on the largest angle. The largest angle will be opposite the largest side. Right. Now here, if we are given this, we don't know what the largest side is. It can either be 12, it can either be x. X can be more than 12, right? We don't know what x is. But it can definitely not be 10, right? So basically, this either there would be a triangle where there's 10, 12, x, and 12 will be the largest, or there would be a triangle wherein 10, 12, x will be the largest. So you have to make a case here. So case 1 would be 12 is the largest. So if 12 is the largest, basically, then the basic properties of triangle says that the sum of two sides should be less than the third side, not even equal to, should be strictly less than. So if 12 is the largest, then basically 10 plus x should be less than 12. X should be less than 2. And also the other relation that you can get is that this angle will be the largest here. So you need to apply the cosine law here. So it would be cos of theta would be equal to x square plus 10 square, which is 100, minus 12 square, which is 144, upon 2 into 10 into x, which is 20x, less than 0. Right. So basically this would have given x square less than 44.
Hello.
Hello. Yeah.
Actually, the equation you have written, that 10 plus x is less than 12.
Yeah.
So actually, it should be greater than 12, right?
Oh yes. Oh, my bad. Yeah. Yeah. It should be greater than 12, definitely. So this gives x greater than 2. And thanks for pointing that out. So and this is cos theta, which is the cosine law, and this should be less than 0 because obtuse. And again, we are only checking for the largest angle, because if it works out for the largest angle, the other angles automatically fall in place. So x square is less than 44 through this, the numerator only, because the denominator is always positive, right? 20 into a side will always give a positive number. So the numerator is what we have to test. The numerator testing gives x square plus 100 minus 144 less than 0. So x square less than 44. So from this case, we have x less than 2, which, as you correctly pointed out, should be less than or greater than 2 actually, and x square should be less than 44. Basically, x should be less than something around 6 point x, whatever. Right. So the permissive, from this case, the permissible values of x would be 3, 4, 5, and 6. Less than 6.xx and greater than 2. Usually people forget to apply the side inequality, but it is important to apply that. So if you just apply this, you would have gotten 0 to 6, but you need to have a lower limit to that as well. So 3, 4, 5, 6 from this case. If x was the largest side, this is the case 2. So then the inequality would be 10 plus 12 should be greater than x, or basically x should be less than 22. This is the first one. And the second one would be that corresponding to this angle, because it is the opposite to the largest side here, cos theta will be equal to 10 plus 12, 10 square plus 12 square, 144 plus 100, 244 minus x square. 244 minus x square should be less than 0. For an again, this is all for an obtuse triangle. So basically, x square should be greater than 244, or x should be greater than 244 root over would be 15.xxx, and x is less than 22. So x basically will be 16, 17, 18, 19, 20, and 21 from this scenario, and 3, 4, 5, 6 from this scenario. So the number of total values possible for x would be 4 plus 6 from here, so 10 values possible. Here there is no double counting as well, so it's fine. But yeah, it's good to just have that sanity check of double counting. But yeah, so x can have 10 values basically, such that, or the third side can have 10 values basically, such that the triangle is an obtuse triangle. So again, questions have come on this previously as well, so it is good to sort of see that application here. Cool. So now it may be useful to just go to the questions, right? If there are any more concepts, it may make sense to cover them as sort of as and when questions start coming up. But may be useful to go through the questions. Any doubts on the theory piece? Like any questions? And again, please be rest assured that we will definitely cover every what is intended to be covered in the workshop. It's not like, okay, we have said 2 days and 2 hours each, so we are bounding it to 4 hours. If we feel that things are getting left or questions are not covered adequately, we will definitely extend the workshop as well, 2 more days or more hours, whatever suits best. So please don't be worried from that standpoint. So now coming to the questions, right? And okay, so this is the first question, and let me just go to this. So in a triangle ABC, point D, and the diagram is given. The naming is not yet done, but yeah, it says that in a triangle ABC. I'll just do the first couple of questions really basically to just basically show the thought process of what you can apply from the given data and from the diagram. Because again, the intent of this workshop is to basically learning how to hit the right concepts in that very limited amount of time of 2-3 minutes, whatever. And in general, a rule of thumb is if you cannot strike the problem within the first 90 seconds, it's better to just skip it. Otherwise, you will get stuck and miss out on other quote unquote sitter questions. Right. So the intent is to basically ensure that we learn how to strike the problem as quickly as possible. So here in a triangle ABC, point D, E, and F are marked on AB, AC, and BC respectively, such that A is to EC, and you know the ratio. So for example, point D, E, and F, so this will be D. E and F are marked, E is on AC, and F is on BC. The side ratios are given. The A is to EC is 2:3, so basically this is 2:3. BF is to CF is 3:5. BD is to AD is 5:4. Right. So just basically denoting the given data itself into the figure. Nothing happening here much. So what is the ratio of the area of triangle DEF to triangle ABC? Right. Now, first things first, if these were parallel lines, if it was given that okay, D is parallel to this, then we have already seen those cases. We can directly use similarity. Like if basically DE was parallel to BC, we could have just used that okay, if the side ratio is 4:5, then like all the side ratios will be 4:5 and the area ratio would be 16:25. Question done, over. But the very fact that these lines are not parallel, and that is why actually you have different ratios. If this was parallel, then all the ratios would have been 4:5, or all the ratios would have been 2:3 or something, if this was parallel. And it would have been a fairly straightforward question. But now here the ratios are different, so how to tackle this? In this case, how to find the ratio of the colored triangle here to the overall triangle, right? Now, since it's the first question, I'll just write down the solution, but I'll tell you the thought process and I'll tell you like how to do it in exam conditions very quickly. I know that the question relates to the areas. Now, what do I know regarding areas? Now, in this triangle DEF, I don't know any of its sides. So obviously I cannot use herons or something here. I don't know any of the sides. In fact, I don't even know any of the angles. So in this triangle, I cannot use like half AB sine A or whatever. Like I cannot use that. In this triangle, I don't know anything. I know only for the outside triangles, right? So that should tell me that, okay, I need to calculate the outside triangles and then subtract from the overall figure to get this area, because it cannot be calculated directly. Okay, that's the step one, right? So calculate others and then subtract from the big triangle. Now how to calculate others? For example, first we take AED and let's just quickly write what will be the area of AED. Will be half into 2 into 4 into sine A. Because again, why did I write this one? Because I know two sides. I don't know what the third side is. And this angle is A, right? Why did I use this? Because I have to compare this with the bigger triangle. So ABC is half. So if AED is, again, this is half into 2 into 4, basically. And this area is half into 2 into 4 into sine A. Using the same sort of sides, what will be the area of ABC? Will be half into 4 plus 5, which is 9, into 2 plus 3, which is 5 into sine A. And again, I'm writing this because I need to take sine A as common so that when we take the ratio, it gets cancelled off. And again, I know that this side would be like, if this is 4, this would be 9, this is 2, this would be 5. So if this is 4 and 2, this would be 9 and 5. Again, these are ratios, these are not exact lengths, but again, we can work on ratios because anyways we're going to cancel it. So if we divide basically AED by ABC, it would be simply 8 upon 45 to say that AED is 8 by 45 times ABC. A very quick way to do it would have, like, you don't even need to write actually. You can just look at the figure. You can just basically write down this result directly, that AED would be 4 into 2 base, ABC would be 9 into 5 base. Half and sine A would be common across both of these, so they would get cancelled off. So it will be 4 into 2 upon 9 into 5, which is 8 by 45. Similarly, if we do for like this one, BDF, the area would be 5 into 3, and for the big triangle, the area would be 9 into 8, right? So it will be 5 into 3 by 9 into 8, which is 15 by 72, or 5 by 24 of ABC. Again, why? Let me just write it down for this one as well. BDF was half into 5 into 3 into sine B, and ABC would be half. Again, we're taking everything with respect to ABC, right? And ABC here we wrote in terms of sine A, here we're writing in terms of sine B because this is, we need to cancel the sine B. If this is 5, this entire side would be 9. If this is 3, this entire side would be 8 into sine B. If you divide this and this get cancelled, this and this get cancelled, you're remaining with 15 by 72, 5 by 24. EFC, similar thing, 3 into 5 by 5 into 8. This entire thing is 5, like this entire thing is 5 and this entire thing is, so basically by 5 into 8. So it's 15 by 40 or 3 by 8. So I've now figured out the 3 triangles, right? So I know, like, apart from DEF, what is the total area I can find out, which is basically 8 by 45 plus 5 by 24 plus 3 by 8 of ABC, right? This LCM is 360. 45 is 8, so 8 into 8 is 64, plus 360, 24 is 15, 75. 368 is 45, so 135. So this gives me 135 and 75 is 210 and 64 is 274 by 360 or 137 by 180 is basically the area of the remaining triangle. And this is a simple like fraction arithmetic, so no need to worry. And so the remaining area, what would be the remaining area? Would be 1 minus of this, so will be 53 over 180. Like basically 1 minus 137 by 180, so 53 by 180 will be the area of ABC, like of DEF upon ABC. So the ratio would be 53 upon 180. Any questions?
No, it is 43, right? 43 by 180.
Okay, yeah, 43 by 180, yeah. It's 43 by 180, yeah. So in an exam scenario, right, you don't need to write down like even 10% of this eventually. You can just directly write down AD 4 into 2 by 9 into 5, so 8 by 45. BDF directly just write down these three numbers essentially. Because half and the sine angle will always get cancelled with the bigger triangle. Just add them and get the remainder. So 43 by 180 is the ratio. Cool. So exam scenario takes like hardly like basically 30 seconds to 40 seconds. That too because like the arithmetic here took some time of the fraction. But otherwise to sort of get to the final point, it takes around like 15 to 20 seconds max. Okay, so this is one. Now going to the next one. ABC is an obtuse isosceles triangle with perimeter 180, AB 80. What is the distance between in-center circumcenter? Before even starting this problem, right? Before even like getting to the working of it, I should have in my memory that the in-center and circumcenter, the distance is given by, as we had discussed, r into r minus 2r, the square root. R is the circumradius, small r is the in radius. Cool. So now I've written this. Now I should start with the problem. Obtuse isosceles triangle, the keywords being obtuse and isosceles with perimeter 180, AB is equal to 80. So if we draw here, AB equal to 80. What is the distance between in-center and circumcenter? Now, the first thing I should directly notice right after writing this formula in my notes is that there should be two triangles possible here, right? So because isosceles it says, so the perimeter is 180. So one triangle could be like 80, 80 and 20. The other triangle could be like 80, 50, 50. Because we are given one side is 80. We are not given anything about the other side. So both these are possible. 80, 80 and 20, 80, 50, 50. Right. But that is why, like, to basically see that which sort of goes ahead, they have given the fact of that it's an obtuse triangle. So again, the test for obtuse is the same as we had discussed. The largest side, check the largest side, like either this 80 or this 80 basically. So this angle and this triangle will check this angle. So for this angle, if we write the cosine rule, so 80 square plus 20 square, like basically minus 80 square should be less than 0, which is clearly not true. Right, so this triangle is not obtuse. 80 square plus 20 square minus 80 square is not less than 0. For here, if we test 80 square plus 50 square minus 50, 50 square plus 50 square minus 80 square should be less than 0, which is true. This is minus 6400, this is less than 0. So this triangle works. Again, cosine law, the included legs 50 square minus the square of the opposite leg. Here also included was 80 and 20, the opposite was 80. So this triangle works. So basically this is the triangle that we need to use, and that is why they gave the obtuse condition. So our triangle is 80, 50, 50, and we need to work ahead with respect to this triangle now. Okay. What do we need for this distance? We need capital R, small r. So we know the formula for both. We can calculate. Capital R is ABC by 4 into area. We know the sides. We can calculate the area. Again, area for an isosceles you can calculate by Heron's. That will also give you the right answer. But the isosceles area we covered, that would be b by 4, 4a square minus b square. This is just a faster method for this. B is the different side, a is the same side. So the different side here is 80, so 80 by 4 is 20, root over 4a square, 4 into 50 square, which is 4 into 2500. Basically this, and minus 80 square, which is 6400. This is the different side. So 20 root over 100, like basically this and this would give you 3600. So it will give you 60. So the area is 1200. So this is the area. And ABC, we know that is 80 into 50 into 50. 2500 into like actually we need to calculate this. ABC by 4a, capital R, would give me 80 into 50 into 50 by 4 times of 1200. So this 4 and 80 get cancelled by 20. So this is 500 by 12. This is capital R. Let me check the calculation here. So 20 into 500 by 12. Yeah. So capital R is 500 by 12. So we know this number now. We need small r. Small r again simple. Area we know 1200. We know the semi-perimeter of this triangle, which is 80 plus 50 plus 50 by 2, which is, and actually the perimeter is already given. So semi-perimeter would be 90 directly. So the small r will be 1200 upon 90, area by semi-perimeter. So which is 120 by 9 or 60 by 3. So 120 by 9 or 40 by 3 actually. Right. This actually also can be reduced to 125 by 3. So capital R is 125 by 3, small r is 40 by 3. Okay, let me just create some space, or maybe we can write here. So we know both the numbers now. The distance between the in center and the circumcenter would be 125 by 3 into r minus 2 times r. So 125 by 3 minus 80 by 3. So which will be 45 by 3. So 1 by 3 comes out. This is 5 cube into 45 is nothing but 3 square into 5. So 1 by 3 into 5 square comes out and 3 comes out. So this will be 25. This will be 25 is the answer. Any questions? Again, wrote the formula and then just check that how can I get to those parameters. So if I can get r and a small r from this, the question is done basically. Then after that it's just calculation. Yeah. So this is a concept that we haven't discussed till now and was more useful to discuss this with this question. So before we start with this question, right, there is a set of very standard formula that is there for this, for the number of triangles with integral sides for a given perimeter. So if perimeter is even, if P is even, the number of distinct triangles with integral sides, obviously if you allow fractional sides, then there are infinite triangles. For integral sides, if P is even, then the number of triangles is P square by 48. This everybody knows. The key point to this is this function is the CIF, or the closest integer function, not the greatest integer, not the least integer, the closest integer function. So like 8.4 will be 8, 9.6 will be 10. So whatever is the closest integer, that would be the number of triangles if P is equal to even, if P is equal to odd, and this is the total number of triangles, right? If P is equal to odd, it will be this P plus 3 whole square over 48. This is again the closest integer. All these formulas are closest integer function. P plus 3 whole square over 48. This is total number of triangles, right? If you want to find, okay, out of these total, how many will be scalene triangles? Like with all different sides. So, yeah.
Can you explain it once more?
Sure. So, if the given perimeter is even, so for example, if the question is that, okay, how many distinct triangles with integral sides are possible with a perimeter of 20? Now 20 is an even number. You just write 20 square by 48, calculate whatever it gives you, and take the closest integer to that. Like the general rounding principle, right? Basically, like if it's like less than 9.5, it will be 9. If it's more than 9.5, it will be 10. That's sort of the general rounding that we do, right? It's not the greatest integer, it's not the least integer. It's just the closest integer. And we'll see it in this question as well. So this is for the total number of triangles, the formula. If we are doing for scalene triangles, like all sides are different, how many triangles, like it will be a subset of this. So just replace p by p minus 6 in the above formula. Just replace p by p minus 6. So if the perimeter is even, the number of scalene triangles, if I replace p by p minus 6 here, will be p minus 6 whole square by 48. Again, the closest integer function. If p is equal to odd, I replace p by p minus 6 here to get p minus 3 whole square by 48. Okay, so I have the total triangles now. I have the scalene triangles now. So if I subtract them, what will I get? I will get isosceles triangles. And equilateral is also considered like within the isosceles only. Right, so isosceles, if I want to find out, it will be total minus scalene. Obviously, right, like all sides different, like all total number of triangles minus the all sides different case will be the isosceles triangles, and this isosceles triangle will include the equilateral case as well. So in general, if the question only asks isosceles triangle, right, you need to include the equilateral there as well. If the question specifically mentions that isosceles but not equilateral, then you will subtract 1 if there is an equilateral triangle possible. For example, in this case, the perimeter is 47 units. There is no equilateral triangle possible. If it was, let's say, 51 units, like a multiple of 3, then one equilateral triangle would have been possible. But that still gets counted within the isosceles. When you do this funda, you just still get counted there. So if they only ask you for isosceles, you have to include the equilateral. If they specifically ask isosceles but not equilateral, you will just subtract 1 here. In this case here, it is not relevant because 47 anyways won't have any equilateral triangles. Right, so now with these bunch of formulae, right? So if we try to do this question now, it's a fairly straightforward one. Perimeter 47, isosceles would simply be total minus scalene, as we just saw. Total for an odd perimeter is p plus 3 whole square upon 48, so which is 50 square by 48, the closest integer function. And the scalene would be p minus 3 whole square by 48. Which is like p into p minus 6 if you replace that formula, so it will be 44 square by 48. Again, the closest integer function. Now, to the query that somebody had, right? Now, if we actually use the calculator to calculate 25, like 50 square by 48, it gives me a number of, I just did it live, so it gave me a number of 52.08. Minus, if I do the same here, so 44 into 44 by 48 gives me 40.33. The closest integer of 52.08 is 52, minus closest integer of 40.33 is 40. So there will be 12 isosceles triangles. Right, so this is from the formula, and this, like, again, it so sort of is, if they ask you this question, they are expecting you to use this formula. Right, the other way to do this would have been if somebody doesn't know the formula, for example, right? So the perimeter is 47, you have sides AAB for an isosceles triangle. So 2A plus B would be equal to 47, and also we know that sum of two sides is greater than the third side always. So 2A should be greater than B. So basically, if you see that for 2A should to be greater than B, then basically 2A can only go up to 24 basically. Sorry, B can only go up to 23 basically. And this is again only for, like, if somebody doesn't know the formula or isn't able to recall, 2A would be greater than B. So from this equation, if the sum of these two is 47 and this has to be greater than this, so B can only go up to 23, right? Well, after 24, B will start getting greater. So B can, the maximum value of B can be 23. So basically the 2A, the limiting value would be 24. If B is 23, the 2A would be 24. So A would be from 1 to 12. These are the 12 triangles. In case you don't want to remember the formula, but this formula is useful. But this is another way to calculate the isosceles triangles, that maximum B can be 23, so 2A can go up to 24, so A can go up to 12. Right, so this is the part A of the problem. Now, in terms of parts B and C, right? All sides odd, all sides odd, you can again take the side that's 2a minus 1, 2b minus 1, and 2c minus 1. These are odd numbers, right? So all sides odd would be 2a minus 1, 2b minus 1, 2c minus 1. Now a good question would be like, why not 2a plus 1, 2b plus 1, 2c plus 1? Even those would be odd, right? But we are not taking that. Why? Because we want a, b, and c to start from values of 1, 2, 3 onwards. If I take 2a plus 1, I will be starting a from 0 essentially. I want to start a, b, and c from 1, 2, 3, etc. Not from 0. So that's why 2a minus 1 works, because here you will be starting from 1. So if all sides are odd, you have sides at 2a minus 1, 2b minus 1, 2c minus 1, and always take, like in case of all odds, all even is pretty straightforward, like 2a, 2b, 2c, but all odd would be 2a minus 1, 2b minus 1, and 2c minus 1. Again, because we are willing to not start from 0. So the perimeter is 47 as given. A plus b plus c would be 25. This we already know. This is in a shape that we already know. So this, the number of triangles with this would be 25 plus 3 square by 48. This is because 25 is odd. So this formula again, like the one we used for 47 in the beginning. So 28 square by 48, the closest integer of this. If I check this via calculator live, this is 16.33. So the closest integer would be 16 triangles. Would have all sides as odd. Okay, so all sides odd would be 16. C is just directly a sort of a result of the above two. Essentially, like I know the total triangles. So basically, if a triangle has an odd perimeter, right? What cases can there be? Either all sides will be odd, or it will have 2 even and 1 odd. There's no other case. 2 odd and 1 even will give an even perimeter. So here we have an odd perimeter, so there can only be 2 cases. Either all sides will be odd or 2 even 1 odd. All sides odd, we just found out that 16, right? Total we know was 52 here. We have found for this part 52 plus 2 even 1 odd. So 2 even 1 odd will be 36. 52 minus 16 is 36. So again, just to recap, total odd perimeter 50 square by 48, 52 triangles. For isosceles, subtract scalene, got 12. For all sides odd, found it by the 2a minus 1, 2b minus 1, 2c minus 1. And for the 2 even 1 odd, just basically subtracted the all sides odd from the total, because there's no other case possible. Cool. So this is another concept. Going to the next question here. A square is, and again, any questions till now, like any concerns till this point? Square is inscribed in a triangle ABC as shown, side parallel to the base. AB is 20, AC is 34, BC is 42. Find the side of the square. So this is a square, so we need to find the side, let's say X. We need to find this. Now, first things first, like this question looks deceptively simple, right? Like basically it looks like, okay, a lot of data is there. This should be easy to find out. Now, if you've not seen such a question before, the general tendency would be like, especially in exam scenarios, right, would be people would be starting to figure out like, okay, if I can find this angle, I can get this side, right? Or something to that effect, basically, right? That, okay, parallel, okay, maybe similarity can be applied, but how? Right, because I sort of don't know the sub-segments of this triangle, right? Like, okay, how much of 20 is within this, within this, within this, within this, or how much of 34 is split, how it is split. But I definitely cannot find the angles, etc. there. So for a person who has not seen this question, they will most likely go the route of sort of trying to apply some sine rule here or some trigonometry based on, okay, this is 90, maybe I can apply something. But it won't, either it will be a very lengthy process and they won't get to the answer. So again, the major hint here is the line, the square means that the side is parallel. So similarity can definitely make our life easy to an extent. Right, so I can immediately say that, okay, if this square is PQ, R and S, I can immediately see that PQ parallel to BC, basically. So PQ by BC will be same as AP by AB will be same as AQ by AC. Why? Because triangle APQ similar to triangle ABC. Once again, why? Because of parallel lines and these angles are equal, corresponding angles. So these are similar. So as we had discussed, that the side ratios will be the same. Now think about what will this give me. Now PQ by BC, okay, x by 42. So at least I have one equation where there is an x. But AB I know is 20, but AP I don't know. AQ I don't know, AC I know is 34. So it won't give me anything, right? Like AP by 20 equal to AQ by 34. It could have been useful if either AP or AQ was given, so we could have used that part of equation. So suppose if AQ was given, we could have used these two. Or if AP was given, we could have used these two. But they are not given, and there's no direct way to find them out. So basically, these ratios may not be able to help us, even though they are correct. Right? So we cannot find x or any leads into x by these equations, right? So okay, what is the alternative? I definitely know that the lines are parallel, so similarity should be giving me something. Now think about what else similarity gives me that we had discussed also. We know that if APQ is similar to ABC, similarly PVR is similar to the big triangle QSC. We had discussed it before, right? Similar to the big triangle because of parallel lines, and like again corresponding angles equal and stuff. So all these small triangles are similar to the big triangle, fine. But we don't have any of these smaller sides, cannot use them. What we can do is that since APQ is similar to ABC, the ratio of sides will be similar to the ratio of heights, as we had discussed. I can find out this height, right? I can find out this height. This height, the entire height I can find out. I know that this portion is x, this is a square. This height I know, this height I know, I can figure out this. So for example, what will be the height of AM? Height as in the perpendicular. So if I were to draw perpendicular here as shown, so for AM basically, right? How can we find out AM? For area of area of a triangle, we know that half into base into height, so half into 42 into h. Also, we know that all the three sides are given, so we can use the Heron's formula as discussed to get the area. So the semi perimeter here, if we quickly calculate, 20, 34 is 54, 54, 42 is 96. So semi perimeter is 96 by 2, which is 48. So this will be root over 48 into 28 with respect to 20, 6 with respect to 42, and 14 with respect to AC. So this is, again, if we 48 is 2 power 4 into 3, 28 is 2 power 2 into 7, 6 is 2 into 3, 14 is 2 into 7. 2 total power is 4, 2, 6, 7 and 8. So outside comes 2 into 4, 2 power 4. Sorry, so 3 total power is 3 square, so outside comes 3. 7, the total power is 2, so outside comes 7. So the area is 16 into 3, 48 into 7 is 336. So H will be basically 336 by 21 from this equation, which is equal to 16. So I know that this entire height is 16. And again, how sort of was I inspired to find out the height? Because I knew that the ratio of sides would be same as ratio of heights for similar triangles. And again, as we had discussed, that this would be the same as ratio of in radiuses, circumradiuses, and etc. everything. So here we are using the altitude proportionality, right? So now the height is 16. So if this entire thing is 16, this is 16 minus x. So I can say that x by 42, the ratio of the sides, will be the same as ratio of heights. So PQ by BC, which is the x by 42, will be the same as 16 minus x by the whole thing, which is 16. Of the big triangle has the whole height, right? 16. So this is 16x. 42 into 16 will be 672 minus 42x. So x will be equal to 672 by 58. This is the side of the square. You can reduce it further, obviously, but yeah, 672 by 58 is the value of x or a side of the square. So again, very good question in terms of applying the fact that similarity works on the ratio of heights as well. Because people generally forget that it works on those. But once you've seen it now it like any figure of this sort, then you'll be able to sort of handle, because immediately your mind will go to the fact of this.